Hi everyone, welcome to Gallant IAS. Tsunami is a very important topic for your preliminary and mains preparation because it is given specifically and it is named specifically in your syllabus along with earthquakes and volcanism as an important geophysical phenomena, meaning that you have to learn it for both prelims and as well as mains examination. Today, we'll take a look at what tsunami waves are. We'll look at what, we'll answer what tsunami waves are. We'll see what are the characteristics of tsunami waves, and we'll see how this changes according to the depth of the water. And finally, we'll see what happened in Sumatra tsunami in 2004. This is our agenda today. Now, what is a tsunami wave? So it has two words in it. One is tsunami and the other one is wave. Let's see what a wave is. Wave is nothing but a process through which we transfer energy from one place to the other. Think about your sun. It transfers energy from the sun through the process of nuclear fusion, process of nuclear fusion. Energy is generated and that energy is transferred through the space and it reaches us. This transfer of energy is done through waves, and waves are a mechanism to transfer energy. Now let's see what a tsunami wave is. So it is a movement of energy, and tsunami waves are movement of energy created in the oceans. So let's dissect this word. Tsu means harbor, nami means waves. So harbor waves, these are both Japanese terms to denote tsunami waves. These are harbor waves. They got this name primarily because the movement of tsunami is not detectable out in the open ocean. We detect it when it comes closer to the shore. We'll learn about it, why it happens, we'll learn about that. But that is the process of tsunami waves. So tsunami is a wave, and wave has certain functions. This waves character is different from other waves. So what are these? We can talk about wavelength, we can talk about speed and amplitude. We talk about all these three things. So this is your typical transverse wave. This is a transverse wave. So as you can see, there are some peaks and there are some valleys or troughs. So distance between one trough and the other trough, or the distance between one peak and the other peak, or what we call crust, is the wavelength. This distance is the wavelength of a transverse wave. That is the wavelength of a transverse wave. Now, before the propagation of this wave, the ocean or the water had a level. Water had a normal relaxed level that is denoted by this line, and the distance between the crust and the normal level, or the distance from the trough to the normal level, is what we call the amplitude. Amplitude is nothing but the displacement of water either above the normal level or to the trough below the normal level. So that is the amplitude. So we know what a wavelength is and what amplitude is. We are familiar with the concept of speed. Now, a tsunami wave is unique because it is a wave of an extremely long wavelength. Now we are talking about a very, very long wavelength, and we are talking about it in kilometers. We are talking about wavelength which extends from hundreds of kilometers. What does this mean? It means that if you notice a crust point where you are standing, you will notice the next crust after 100 kilometers. That is the difference. So if you notice a trough, to notice another trough, you have to travel 100 kilometers. That is the scale in which we are talking about. We are talking about kilometers. Now, what about the speed of the tsunami waves? Tsunami waves are known for its speed. It is really, really fast. It exceeds 500, 600 or even 800 kilometers. That means it travels in such a mind-boggling fast pace that it would be harder for humans to react. Even if we are able to detect the incoming tsunami wave, it would be harder for us to respond because the time to respond to such a disaster is very, very less. The window to respond to this disaster is very short. So that is the reason why we have to prepare in advance for such an emergency. So we have to prepare in advance, thinking ahead to prepare ourselves and our infrastructure so that we can face the oncoming tsunami wave. Now, what about amplitude? We talked about wavelength, we talked about speed. Both are extremely high. We have a large wavelength and an extremely large speed. What about amplitude? Now, amplitude is very less. That is, the distance from the crust to the normal water level, or from the trough up towards the normal water level, is very less. The displacement of water is only a few inches. Water rises only a few inches in the open ocean. Remember this word, it is very important. Open ocean. We are talking all about tsunami waves as we can find it in the open ocean. We have to remember that all this character that we talked about, that the long wavelength, high speeds and low amplitude, that it rises only few inches, all that are characteristics of tsunami waves, but characteristics of tsunami waves as we see in the open ocean, not at the shallow end. We'll get to that. So in the open ocean, tsunami waves has extremely long wavelength, extremely large speed and very low amplitude. This is the character of tsunami waves out in the open ocean. Now we learned the characteristics. Let's think what would be the causes of tsunami waves. Now tsunami waves require large amount of energy. It is not caused by tides. It is not caused by wind. Remember that. But where do we get this large amount of energy? We get this large amount of energy through plate movements. So we know the Earth's crust, that is the top layer of the Earth, is dissected, it is differentiated, it is divided into irregularly shaped lithospheric plates. Irregularly shaped, meaning that it is not in a regular shape. Every crust is different, every plates are different. Irregularly shaped lithospheric plates, and these plates are constantly moving. Sometimes they are crashing into each other, sometimes they are going apart from each other, sometimes they are sliding past each other, and we call them convergent, divergent or transform boundary respectively. So all these movements, that the movement of Earth's plates creates conditions required for the generation of large amount of energy in the forms of earthquakes. Okay, that can lead to the formation of of tsunami if it happens underwater, if it happens under the sea. So earthquake can cause tsunami waves. Earthquake can cause tsunami waves. What are the other? Underwater landslides, meteor strike, volcanic eruption. All these can cause tsunami waves because it releases large amount of energy, and waves are a series of process through which we transfer energy, right? So we know this line. It is very common that energy cannot be created, nor it can be destroyed. It can only be transferred. It can only be transformed. It can only be transformed. One form of energy can be transformed to the other. It cannot be destroyed. So an asteroid strike or an earthquake wave is transformed into a tsunami wave. Now we know it is either earthquake wave or an undersea landslide or a volcanic eruption or a strike of an asteroid, all this can cause earthquake. But one important aspect that you should remember regarding tsunamis is that we need one important thing, that is we need vertical displacement. We need vertical displacement of water column. We need to push the water up like this so as to generate a tsunami wave. A horizontal movement will not cause tsunami wave. Remember that. A horizontal movement will not generate an earthquake wave. We need a vertical displacement. So let's imagine what happens in a vertical displacement. How the energy is created, how it is transferred. Let's imagine that. This is your normal sea level, right? Something happened, earthquake or a volcanic eruption, something happened, and the water level is pushed up. It is vertically displaced, right? It is vertically displaced. The normal level, it is displaced level. So the water column, the entire water column from the depth is rises up to transfer this energy. And what happens if anything goes up? It must come down under the influence of gravity. It falls back down to resume its original position, and this generates a wave which propagates in either direction. In all the direction, it propagates out from that position, out from that point. This is how an earthquake can lead to the formation of tsunami. This is how a transverse tsunami wave is generated. So we talked about wavelength, speed and amplitude. You know what are the difference of wavelength, amplitude and speed, and we know wavelength and speed is much higher out in the open ocean, and amplitude is very less. It rises only a few inches. It is barely detectable. That is why we can't predict a coming tsunami, because it is nearly indistinguishable to other kinds of motions of the ocean, motions created by either the movement of ocean currents or wind or tides. All these are indistinguishable in the open ocean, because when we take a look at it, it only rises a few inches, barely detectable. But the character of the tsunami waves changes drastically as it moves towards the shallower part of the ocean. What is that change? It changes as it moves to the shallow part. We are talking about the open ocean. Now as it is moving towards the shallow part, it changes. You can imagine ocean as a big, large, giant basin. Okay? And necessarily, the giant basin must have places where it is very deep. If this is your water level, it is very deep here. But as you move in either directions, the depth reduces. In other words, as you move towards the shore, the depth of the water reduces. Okay, and this changes the character of tsunami waves. This brings about a change in the character that we talked about. So it changes wavelength, amplitude, and speed. All these three changes as the wave moves towards shallower part of the ocean. What happens? The wavelength reduces. It is compressed. Wavelength reduces. What happens to speed? Speed also reduces. So both wavelength and speed reduces, but amplitude increases enormously. That is, the height of the tsunami wave increases. This is what happens. This is the cause of destruction when tsunami approaches the shore. The height increases dramatically. It goes up meters and it lashes down onto the shore, destroying our infrastructure, destroying the lives of our fellow citizens, destroying the income, their prospects. All are under peril because of a tsunami wave, similar to what happened in 2004. So this change is called shallowing effect. What is shallowing effect? It is a character of tsunami wave that it changes from as it moves from the open ocean to the shallower part. The character of the tsunami wave changes. How does it change? It changes, wavelength reduces. It is compressed, wavelength is compressed, it is more closer. Look at this, it is more closer. The difference between wavelength is much closer, between trough much closer, and the amplitude, the distance from the normal sea level increases enormously. Amplitude increases, speed reduces. As you go towards the shore, the speed of the tsunami wave reduces. And all this combines to happen one phenomena, that is shallowing effect, and this leads to stacking up. Meaning more and more and subsequent waves stacks up and rises in height, and this finally falls onto the ground, destroying everything. So this is the character of the tsunami waves, and this is how the character changes as the depth of the ocean changes. Okay, now let's talk about what happened in 2004. We know the large amount of energy that requires to generate this large amount of wave power comes normally from plate tectonics. So plates are either converging, they are either diverging, or they are sliding past each other, transform boundaries. India happens to lie close to a converging plate boundary. That is, the Indian plate, that is our homeland plate, is ramming into the northern plate, that is the Eurasian plate. That is what happened in 2004. In 2004, there was an earthquake in a magnitude of 9 Richter scales off the coast of Sumatra, which triggered the release of a large amount of energy, which displaced water vertically, caused the formation of a very large, powerful and destructive tsunami. That is the reason. And what caused it? It is the movement of Indian plate. Indian plate was subducting to the Burma plate, and the sudden subduction caused the release of large amount of energy, an earthquake. Because it happened out in the ocean, it generated a tsunami wave which created destructive forces which destroyed lives and property along the coast of India. So that is what happening in tsunami waves. So let's recollect what we learned. We learned what tsunami waves are. Tsunami waves are nothing but a series of waves with long wavelength, very high speed and low amplitude, which rises only a few inches out in the open ocean. But its character changes as we move towards the shallower part of the ocean, as we move towards the shore. Speed reduces, wavelength reduces, but amplitude, the height, increases. This is what we call a shallowing effect. And in 2004, what happened? There was a major tsunami which happened close to Sumatra because of the subduction of Indian plate. So, any subductions or volcanic eruption or even an asteroid strike or a landslide under ocean could potentially lead to the generation of a tsunami wave, which is very destructive. So that's all about tsunami waves. I hope it is clear to you. Now, before we finish, don't forget to subscribe to our channel, press the bell icon. We'll keep in contact. Thanks for listening.